Nice. All right. Well, we're going to bring up our next presenter, Mori Hayes. His project was Integrated Renewables in Greenhouses, and his mentors were Daisy Huang and Michelle Wilbur.
Oh, thanks, Jeff. Okay, so my project was investigating greenhouses for food security. My mentors were Michelle Wilbur and Daisy Huang. So the basic idea of this project was to investigate strategies of community food production infrastructures in Alaska with regards to using greenhouses and hydroponics, and especially wintertime food production, and gather information and draw conclusions from past research under the Microfuse Project. So some background on this Microfuse Project. This is a large research project to investigate their interactions of food, energy, and water security, or water infrastructure in rural Alaska. This is funded by the National Science Foundation, and it's being done by an interdisciplinary team of engineers, social scientists, and independent contractors. This 5-year project is now coming to an end, so it's kind of part of my role is to look at what were some of the things researched with this, and as far as food security, and make some conclusions. So as far as my project goals, I was looking at reviewing and learning about the past greenhouse research done under this project. There's a couple of class projects, and then also some graduate student research. And then also research some answers to these following questions. What are some good greens to grow in greenhouses in Alaska? What is an optimal greenhouse system, especially for running year round? What are advantages of hydroponics over traditional growing? And what are some commonalities of successful greenhouses in rural communities? I think I'll just explain some terms. So hydroponics, for those who don't know, is like when you grow without soil and you mix fertilizers into the water, and then you either have the water sitting beneath the plants or running below them, and the plants are sitting in some sort of inert medium. So as far as research performed, I reviewed the papers and that were done for past research, and talked with some local experts, some greenhouse managers. Also learned about hydroponics, greenhouse operation, and renewable systems such as solar panels and geothermal. And then after talking with my mentors and discussing, we developed the idea to do some interviews and talk with various community greenhouse managers and see what sort of systems were working best in Alaska. So we developed some questions to ask these greenhouse operators, and then contacted 16 different greenhouse operators in rural Alaska. Was able to actually get in contact and either talk with or email 8 different greenhouse operators. And then this final part of my project was looking at how to optimize the HVAC system of the Kewaunee Lake Research Station container farm. This is an existing container farm at Kewaunee Lake. So these are the locations of the greenhouses that we were able to contact. There's a couple in Fairbanks. There's one in Manly Hot Springs, one in Polk, and then a couple down in Southeast. So lessons learned from these interviews: wind and solar can be implemented on greenhouses, but it seemed like using battery storage systems was really not cost effective, since it's pretty expensive. Also, almost all these greenhouses are funded by state grants or like grant funding, which can make a kind of an unstable environment, since these grants they renew every year to 2 years. So some years they'll have funding to hire somebody, and then other years they have to rely completely on volunteers, which can make it really hard for the people running it. Many communities also suffer from poor soil quality. So hydroponics, which doesn't use soil, is a good solution. It does mean though that people have to be more technically adept, because it requires pumps and machinery, which can be a challenge in rural places. And then the greenhouses make sense where excess heat is available for, so for example, like biomass boilers in schools is becoming popular in Alaska. And so a lot of these schools have built greenhouses that use that excess heat. And but really there's no examples of just greenhouses being powered by just like electric heaters, for example. This is some information on the container farm model that I was looking at. So in the upper left, there's a photo of a container farm. These are like Connex containers, shipping containers, and then there's companies that kind of gut out the inside and sometimes insulate if they don't have insulation, and then install an HVAC system, and then some lighting and racks. And so you can grow food hydroponically inside of there, and it's kind of a modular system, so you can send it anywhere. We took the heating, lighting, and ventilation numbers from the Kalani Lake container farm, and then plugged those into a MATLAB script, and used Excel, and then made these graphs down at the bottom. This doesn't account for thermal mass, so I know this for you mechanicals who may be looking at this, it's not, it shouldn't be instantaneous heat like it is, but it's a good starting point. And so the next step for this model would be to analyze how to minimize heating and cooling with adjusting different factors like ventilation, and then also maybe adding in some more thermal mass than just the container itself, and seeing if that would be able to make it work better. So some things I learned from this model is ventilation is a really big need for container farms. Heating isn't as important because LEDs surprisingly produce a lot of heat when you have a lot of them in an insulated container. So these container farms really only need cooling like 2 to 3 months out of the year. They're really only best for leafy greens. So if you want anything else, like it can be challenging to grow those things. And then also these container farms have been getting really popular in Alaska in the last 5 years or so, which is pretty exciting, because they allow people to grow things in the winter, and provide things that rural communities might not usually have. Some future things to look at, if somebody were to look at continue this research, looking at container farm operations in Alaska. So seeing maybe some of these new container farms and seeing how well they're working or how their systems are working. Another point that a lot of people brought up that I talked to is commercial marijuana hydroponic operations are really efficient in Alaska, and they're all over in a lot of small towns. So somebody should look into that. And then expanding that container farm model, I started to find an ideal HVAC system for interior Alaska container farms. Yeah, thanks for listening. Any questions? Yeah, cool. Yeah, so the question is, are there any vegetables that can survive winter without any lights? And you're talking about indoor, like they still have heat and um, not that I know of. All of the green, even the greenhouses that ran in the winter, they used supplemental lighting. So I I don't know of any vegetables that can survive without lighting. Yeah. Uh, oh, yes, Rich.
Yeah, so one of the real disadvantages, you've got all that excess heat coming out of your shipping container facilities. And yes, those are only leafy greens. If you were at a lower latitude site, you could co-locate those next to a high tunnel or greenhouse. And in the colder months, exhaust your heat that has to be ventilated out of that shipping container into an adjacent high tunnel or greenhouse. The problem you have as you move farther and farther north is you still need that light in addition to heat to grow your dirt vegetables. But if you could do that at the right latitudes, you could combine the same energy for both leafy greens and for ground based vegetables. So I don't know if you kind of considered, hey, where's that spot where there's a magic to pair those up, kind of a ideal Goldilocks zone.
Yeah, that's a great point. That's not something I thought about, but that would be something to look into. I guess there's a lot of different ways people use the exothermal mass. So for other people, the idea with thermal mass is using some sort of large object that stores heat, and then that heat is stored, and then over time, when like during the winter or during the night when it gets colder, that object radiates the heat back out, so you don't have to generate heat when you already have it. There's several, I guess, like for example, you could use maybe concrete, or like people use rocks too for thermal mass. I think the problem with thermal mass, and especially in a container farm, is that it's such a small container already. So there's a lot of materials like phase change materials, which you can buy that are thermal masses that would be a lot more efficient at using space. So I think that would definitely be a challenge. Yeah. Yeah. So the question is, are people using water as a thermal mass storage? And yeah, I mean, oh yeah, like a lot of these hydroponics, they do have a fair amount of water in them, especially like in Prince of Wales, they use aquaponics. So they have like these huge tanks full of goldfish, and they store a lot of heat. So I think in some of those instances where they are having a lot of water, it already acts as a large thermal mass. So I'm not sure how much adding a little extra would do. Yeah, for sure. So like aquaponics is using fish to fertilize the water, instead of where hydroponics is you manually or have systems where it adds the fertilizers into the water, because the plants, they can't just survive off water. They need things like nitrogen and calcium phosphate, things like this. So with aquaponics, you have like people usually use tilapia. They're like a fish and then they excrete their fluids into the water. And then that is used to grow the plants. Yeah, and it's nice because it's a little more efficient than hydroponics. Jeff. Yeah. Okay. Yeah, I think it seems like it's definitely been an issue how high tech they are. Like so Jeff's question was kind of what the issues with labor and maintenance are on these container farms. I think there's a lot of companies coming out now that have better systems. Like there's a company in Anchorage, and they're based out of Anchorage, and they build these container farms and they've shipped them to different parts of the state. But there's also a few container farms that have been like custom built. And I think as people build more of them, they'll be more optimized for Alaska and then also for ease of use. Mari. So the question was, do you still have to provide supplemental heat to a container farm, or is it able to run just with the heat from the LEDs? From that example in Quaney Lake, they had to use supplemental heat occasionally from like November until February. And so it's pretty cold there. I don't, maybe a little warmer than here, but pretty cold. So I think in like those kinds of instances, you do have to use supplemental heat, but I would imagine like in Southeast Alaska or in South Central, you probably wouldn't have to use supplemental heat. Longer than